Bam, Mr. True. We are going to do 3 examples of solving trig equations with single angles, where you just have a variable of just x, not like a 2x or 3x. That'll be in the next video. And it's kind of a repeat of a video I've done before, except this time, instead of only accepting answers between 0 and 2 pi on our unit circle, or 0 to 360, that restriction that my textbook keeps on most of these trig equation problems, we're going to find all solutions to the equations. We're going to allow our solutions, we're going to allow ourselves to rotate around this unit circle in both a positive and a negative direction an infinite number of times, and thus have all possible solutions to this equation. We are going to do 3 examples, and let's get started. So we have 2 cosine squared x minus 1 equals cosine of x. Now I have a squared term and a single degree term, plus I have a constant. So we're going to need to get this equation set equal to 0 and hopefully be able to factor it. Otherwise we're going to have to use the quadratic formula, which will be actually our 3rd example. This one will factor. So I'm going to move my cosine of x to the left with subtraction and get 2 cosine squared x minus cosine x minus 1 equals 0. And now we're going to look for, to see if this trinomial, this quadratic, is factorable. If your first term is not equal to 1, and these are both prime numbers, we could probably guess and check our way to the answer fairly quickly. But if your first leading coefficient is not equal to 1, you can take the first and last constant, or the coefficients of 2 and negative 1, multiply them together, and you get some kind of product that on its own is, doesn't mean a whole lot. But we're going to now look for factors of that product, that negative 2. We're going to look for factors that add to the middle coefficient of negative 1. And since 2 is prime, it's not going to be very hard to do. Negative 2 times 1 equals negative 2, and negative 2 plus 1 equals negative 1. That middle term that I have, that middle coefficient of negative 1, which I can just write in here to make it a little bit clearer. So what I'm going to do is, I'm going to use these 2 values to rewrite my middle term and then factor by grouping. So we have 2 cosine squared x, just copying that first term down. I'm going to break up this middle term using these 2 numerical values of negative 2 and 1. So we're going to have negative 2 cosine x plus 1 cosine x. Writing those 2 terms to make the middle term look different, minus 1 equals 0. Now in these first 2 terms, I'm going to factor by grouping. In these first 2 terms, they both have a factor of 2 and they both have a factor of cosine. So I'm going to pull that 2 cosine out and get 2 cosine x. 2 cosine squared x divided by 2 cosine x is cosine x. And then 2 cosine divided by 2 cosine is, of course, 1. These last 2 terms, we have cosine x minus 1. Well, inside this parentheses, I have cosine x minus 1. I'm looking for a matching set of factors. But I still have to show that I'm, when I factor by grouping, I still have to show I'm pulling something out of those last 2 terms. And since it's already a perfect match, I'm going to factor out a positive 1, which is just sort of going to complete the process, but not really change anything. Of course, when I divide by 1, nothing does change. So I get cosine x minus 1 again. Now I have 2 big terms separated by this 1 plus sign, and these 2 terms both have a cosine x minus 1. So I'm going to once again sort of undistribute or factor that cosine x minus 1 out, and we get cosine x minus 1. And this term divided by cosine x minus 1 is 2 cosine x plus this 1. And these are equal to 0. Now, once you get done factoring, you set each factor equal to 0. Set each one of these equal to cosine. We're just going to add 1 to both sides. Subtract 1, and I'm going to divide by 2. And we get cosine x equals 1 and cosine x equals negative 1/2. With the unit circle to look at, we could probably just write down the answers, but to just add that extra step of clarity and you might be just learning this for the first time, so you need to see all those steps. We're going to get the cosine function away from the x, not by dividing, because it's not cosine times x, it's cosine of x. It's actually a math function. We're going to undo that math function with the inverse function, kind of like you undo addition with subtraction. We're going to undo this by doing the inverse cosine function to both sides of the equation and get x is equal to the inverse cosine of 1 and x equals the inverse cosine of negative 1/2. And now we're going to draw our attention to the unit circle. And where is cosine equal to 1? Well, around the unit circle, remember cosine of an angle is x over r, sine is y over r. And if we're on a unit circle, cosine is simply the x-coordinate. So the cosine, where is cosine? What points have a x-coordinate of 1, and that's 0. So the inverse cosine of 1 is 0. Where around the unit circle is the cosine values, the x value equal to negative 1/2? Well, that's here at 2 pi over 3 and at 4 pi over 3. Well, these would be my three answers if I were looking for my solutions within one rotation. I had a restriction that, theta had to stay between 0 and 2 pi. But I want all possible solutions. So I want to just allow myself to keep, rotating around the circle. It is a circular function, so you're going to have repetition as you continue to rotate around this 360 degrees or 2 pi, and you'll hit these points again. I'm going to hit 1 after, or the 0 degrees after I rotate another 2 pi, or I should be saying, I have degrees on the inside and radians on the outside. Getting myself confused because I'm looking on the inside of the circle, but I have my answers written in radians. I can rotate 2 pi and get to 0 again. I can rotate 2 pi and get to 0 again. I have an answer of 2 pi over 3. Well, if I rotate another 2 pi, I get back to that same coordinate, or I could rotate, backwards. The period of sine and cosine, and secant and cosecant for that matter, is 2 pi. That's because you have to go all the way around the circle to see that number repeat. So I'm just simply going to say, here's one solution within that first rotation. Let's go through and add 2 pi n. And I'm just going to verbally say this because I'm running out of room to write. N is an integer. That could be, it's a positive 3 or a negative 5. So if n is allowed to be an integer, that's going to count as, do you want to do one full rotation of 2 pi to get back to that coordinate here? Or do you want to do, let's say, 3 more rotations of 2 pi to get back to that 0? And so on. The n is just going to allow us to say it's an integer, and then basically what we're going to put here is the period of the trig function we're dealing with, and that'll change more on the second video. So this is going to be 2 pi over 3 plus 2 pi n, the period of sine or cosine for this problem, and then integer rotations of that, and same thing with the 4 pi over 3. And that is not just the solutions between 0 and 2 pi, but with that plus 2 pi n, 2 pi being the period of cosine, n being an integer. Now I've got solutions, or, all of my possible solutions. Let's get this board erased and do our next example. Bam! For our second example, we have cotangent squared x plus square root of 3 cotangent of x equals 0. I have a quadratic again. I already have it set equal to 0, but my two terms have a common cotangent factor, so this factoring is going to be a little bit quicker than the last example. We're going to take this cotangent x out. Cotangent squared divided by cotangent is cotangent. And 3 cotangent x divided by cotangent is just, well, square root of 3. Equals 0. Well, we have it, we're done factoring. Let's set each factor equal to 0. Get the cotangent functions alone, so we're going to subtract both sides by square root of 3. And now we have to get the cotangent function away from the x's, and that's going to be using inverse cotangent. So x is equal to the Inverse cotangent of 0. And the inverse cotangent of negative square root of 3. Now, let's not forget that the cotangent ratio is either, think of it as either cosine over sine or x over y, depending on how your teacher's been teaching it. But I'm sure it's just x over y with, well, you have it in both forms, so forget that. Saying x over y might be a little bit confusing because we have the variable x in our equation. But going back to the unit circle, the cotangent ratio is x over y, or cosine over sine. So where do I take a cosine and divide it by a sine value, or x over y on the unit circle, and get an answer of 0? Because this is an inverse trig function, so inside that function is the ratio that we have, and we're looking for the angle measure. So, okay, be right here. X over y, or cosine over sine, that's going to be 0 divided by 1. When a fraction, a ratio, has 0 in the numerator, then the entire ratio is equal to 0. So the only way for cosine over sine, which is what cotangent is, to equal 0 is if cosine is equal to 0. So the answers to this, they are pi over 2 and 3 pi over 2, because you get that x value of 0 down here as well. As far as my second ratio, well, again, I'm looking for a cosine over sine to equal negative square root of 3. Now, cotangent or tangent being negative, that must be in quadrant 2 or 4, because the x and the y variables must have different signs. Quadrant 1, they're both positive. Quadrant 3, they're both negative. So we're looking for an answer in quadrant 2 and 4. And I have a square root of 3 here, but if I do x over y, or cosine over sine, I'm going to have to rationalize that square root of 3 out of the denominator, and that will be the right answer. We are looking for 5 pi over 6. Cosine will be negative square root of 3 over 2 divided by over the y, or the sine of 1/2. Those common denominators are going to cancel out, and we do get a ratio of negative square root of 3. So this answer is 5 pi over 6. And let's see. I got a positive and negative 1. I have the x being square root of 3 over 2 and the y being 1/2. And 11 pi over 6 have the same thing. The signs are different, but we have the same cosine and sine value, or x and y value, on the unit circle. One positive, one negative. So 11 pi over 6 is the same answer. Well, going to give you the ratio of negative square root of 3. Now, in the previous example, we were using cosine, and cosine has a period of 2 pi. Now, these would be the 4 answers if we were restricting our values between, to be between 0 and 2 pi, but I want all possible solutions. So I could come through here and remember, now, why are these being separated? Why we got pi over 2 and 3 pi over 2, the opposite side of the circle. I got 5 pi over 6 and 11 pi over 6. Those are on opposite sides of the circle. That's because the period for cotangent is pi and not 2 pi. So I can just take one of these answers. I'm going to take the smaller one, and say, if I want all my solutions, I'm going to take pi over 2 and then add it with pi n. Again, pi because it's the period of cotangent, and n can be an integer, so we can talk about positive n's where we continue the positive rotation, or negative n's where we do the negative rotation. And I'm going to pick the smaller of these two values of 5 pi over 6 and write that right here. And together, these are all solutions to this equation. And we have one more example. It'll involve the quadratic formula if you want to just, continue that review, that example of solving these trig functions or trigonometry trig equations. My last example is not going to factor. We have we're going to ask to be solved for sine squared x minus sine x minus 1. Now I know this is not going to factor because my leading coefficient's not 1, so I'm going to take the first and last, multiply them together, and get a product of negative 4. Now, there are no factors of negative 4 that add to be the middle coefficient of negative 1. So this will not factor. Thus, we're going to need to use the quadratic formula to finish this answer, and we're not going to get answers that are right off the nice unit circle. We're going to have some decimal form of these answers. That might make it a little bit difficult for you to understand or identify all the possible answers, so of course I'm going to help you with that. A is going to be equal to 4, B is going to be equal to -1, and C is going to be equal to -1. And we're going to use the quadratic formula, which is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But it's x equals, right? But my variable is not just simply x, it's sine of x. So I'm going to have the sine of x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to pause the video and finish writing this out to shorten this up just a little bit. You may want to try and solve this yourself and then see if my solution matches yours. I'll be back in just a second. Here we go. So I've plugged in my values of b, a, and c, and a. -1 squared is 1, 4 times 4 is 16, the two negatives make a positive 16, and my quadratic has come out to be 2 plus or minus the square root of 17 over 8, and then that simplifies down to 0.64 and -0.39. So sine of x equals 0.64, sine of x equals -0.39. I apply the inverse sine function to both these equations, and I get 39.8 degrees. And I'm going to go ahead and do degrees because once you start getting decimal answers of angles, I think it makes it a little bit easier. And -23 degrees. Now, let's talk about this 39 degrees. Sine is positive. The sine of x, the sine of an angle, gives you a positive value of 0.64. Sine is not positive in only one quadrant. Sine being y over r is positive in 2 quadrants. So while the calculator was able to give me an answer in quadrant 1, I need to find my own answer in quadrant 2, which will have this same reference angle of 39.8 degrees. So I'm going to go over here to 180 and back up, because I want to stay in quadrant 2. I'm going to go up or subtract 39.8 degrees. So 180 minus 39.8 is equal to should be 140.2. And draw my attention over here, just out of habit, because I don't like giving negative answers for angle measures. The calculator was only able to give me -23 degrees. Well, the sine of x is equal to a negative number. That y over r is a negative ratio, which means that the sines, or I must be getting sine values out of quadrants 3 and 4. So I want an angle in quadrant 3 that has a reference angle of 23 degrees. So I'm going to do 180 plus 23 and get 203 degrees, roughly, because this is rounded off. And I want an angle in quadrant 4 that also has this reference angle of 23 degrees. Remember, reference angle is an acute angle, and it's the number of degrees the terminal side is away from the x-axis. So I'm going to go, okay, I want something in quadrant 4 because sine is negative in quadrant 4. That's 360 degrees. I want to back up 23 degrees and get 360 minus 23, which should be 360, 340, 337. Now, just double check that. Okay. Now, I don't want all answers within 0 to 2 pi. I want all possible solutions. And with the period of sine being 2 pi, I'm just going to come through with all of these and add, well, I have these in degrees, so a period of 2 pi or a period of 360 degrees. So I'm going to come at all these answers and just simply add in $368. And that's 3 examples of solving for all possible solutions, solving these trig equations when they have one single angle. Next video will be for multiple angles. I'm Mr. True. Bye! Go do your homework.